You've probably heard of the Internet of Things, or IoT, right? It's this huge, invisible network of connected devices that's already changing our world. But have you ever stopped to wonder, how did billions of completely different gadgets actually talk to each other? Well, in this explainer, we're going to pull back the curtain on the universal blueprint that makes it all work. Let's dive in.
Okay, first things first, let's just get a handle on how massive this IoT universe really is. And I'm not talking about some sci-fi future here. This stuff is already all around us, working away in the background of our daily lives.
And this slide gives you a perfect snapshot. We're seeing IoT powering entire smart cities, making farms way more efficient, creating intelligent buildings that manage their own energy, and so much more. You know, from your smartwatch to the power grid, it's a giant connected web of things. So that brings up a really big question. I mean, you've got devices from thousands of different companies, all designed for totally different jobs. You've got simple little temperature sensors, and then you've got these super complex industrial robots. How on earth do you get them all to speak the same language and actually cooperate?
Well, the answer isn't to create a custom solution for every single new gadget. That would be chaos. Instead, the smart way to do it is to create a universal blueprint, a common framework that everybody can build on. That way, you know that whatever you make, it's going to fit into the bigger system. In the tech world, this master blueprint has a name. It's called an Architectural Reference Model, or ARM for short. Honestly, you can just think of it as the ultimate instruction manual for the IoT. It sets out the common language, the rules of the road, and the basic structure you need to build any IoT system so it can play nicely with others. And this diagram, it shows that process perfectly. See, over on the left, you start with the business idea. The architectural reference model, the ARM, acts like a bridge, guiding engineers to turn those abstract ideas into a real, functional, and standardized system that actually works. Okay, so let's zoom in on one of the coolest ideas in this whole blueprint, the idea of giving every physical object a digital life. This is the heart of what's known as the information view. It's such a simple idea, but it's incredibly powerful. For every single physical thing, whether it's a car, a streetlight, or a package, we create a virtual version of it in the digital world. This is often called a virtual entity, or maybe you've heard the term digital twin. And that twin holds all the important information about its real-world counterpart. This slide just nails the concept. In the real world, you've got a car parked in a spot. In the digital world, that physical space is represented by an entity called parking spot #16. So now, a system can know its status. Is it occupied or empty, without anyone having to physically go and look? That's the information model in action. So we've seen how the information gets organized. Now let's go into the system's engine room and see how it all functions. This part of the blueprint is called the functional view, and it lays out all the essential building blocks of any IoT system. Okay, at first glance, this diagram might look a little intense, but don't worry, it's actually just a really logical map. It lays out all the different jobs that need to get done inside any IoT system, from the physical sensor all the way up to the app on your phone. Let's break it down into a few key groups. It all starts at the bottom with the device. That's the actual thing with sensors out in the real world. Then you've got communication, which is the network that carries the data. That data flows up to the IoT service layer, where it gets processed and connected to its virtual entity. Yep, that's our digital twin again. Near the top, you have the application, which is how we actually use the data. And then wrapped around the whole thing, you have management and security, making sure everything runs smoothly and safely. A really great way to think about these functional groups is to picture them like the services of a city. The communication group, that's your road and transit system. The security group, that's the police force protecting everything. And the management group is kind of like City Hall, just making sure all the other departments are doing their jobs right. So, you might be thinking, how does this abstract model, this city plan, actually connect back to all those real-world applications we saw earlier? Well, the magic is all in standardization. Because everyone is using this same basic blueprint, every new IoT solution is built with the same functional blocks. This creates interoperability, a fancy word that just means different systems can finally work together. And that is the key. That's what makes a truly smart city or a smart factory possible. And this slide just shows you the amazing result. That single, standard model allows for this incredible explosion of different applications, from smart grids to self-driving cars to precision agriculture. They all share the same basic architectural DNA. It's one unified foundation for a whole world of innovation.
So, by having a clear information view and a solid functional view, this blueprint doesn't just organize what we have now, it gives us a stable, scalable foundation for whatever comes next. Which leaves us with a pretty exciting question. With a blueprint this powerful, what kind of intelligent, connected world are we going to build next?